sessions as we could.
All right. Sounds like it's picking me up like way too well. Not sure.
I think they'll make any
Sounds like it's picking me up like way too well.
Oh, can you turn on your 360?
Yeah. I get picking up a bunch of stuff.
Never got into it.
But it's a delay. It's not like I can. No, I think we're okay. Check it real quick on my phone.
Are we streaming now?
We are streaming, but I just have it as the. I have it as the. Yep.
That's essentially how my entire movie collection. Dang, I hope you didn't break your neck. No. Networking, downloaded a bunch of social videos would work.
Testing.
How can someone have that much? How much of it do you actually listen to?
Like you can
Exactly. So why waste? I can see if you're a DJ or something.
Right.
But other than that,
Oh no, it was quite literally was a LAN party and all my buddies that were on the network.
sure there's pieces. They just
pulled it all
Store
over.
information.
roll with it. Ready to go.
Yeah.
All right, good evening, everybody. Welcome to misec. Stop playing Pokemon and start tweeting. This is serious. I am obviously not Kyle. He couldn't be with us tonight. As you know, the Olympics are going on, and the men's soccer team bailed because they're a bunch of sissies. So Kyle is going to go carry our country and crush everybody. Tweet Kyle Gold 2016. But here in Michigan, Mark Good is going to be presenting Injecting Security into SDLC, Sideways Development Layer Control or something. I'm a network guy. I have no idea what this is all about, which is why I'm going to turn it over to Mark in just a moment. Kyle did leave one memo for us. Okay. Have you ever tried to eat a clock? Anyone? I know some of us are hungry. Have you ever been that desperate? Well,
Come on, Sam.
it's,
Say it.
It's very time consuming. Oh.
Did you get that off the popsicle stick? Probably.
All right, I guess let's get started. Thanks for coming. This talk is on injecting security into the SDLC. I'm really honored that you're here 2 weeks before school starts, and last couple weeks of summer. So thank you. In this talk, you'll learn why it's important to include security during development, what activities should be performed, and when to perform those activities. But first, let me tell you a little bit about myself. My name is Mark Hood, and I'm an application security architect at Consumer Energy. I've been with Consumer Energy about 17 years. Most of this time has been spent as a developer. I spent a few years as an application architect, and in the last 6 months to a year, my focus has been on secure coding and reviewing code reviews for developers. So I have 3 GX certifications and 3 somewhat dated Microsoft developer certifications. So how about you? How many developers are here? Any developers? Few? 4? 5? Good. How about security engineers, managers? All right, good. Thanks. Well, again, thanks for coming. During this talk, I want to start with some motivations for security during software development. I want to review what a traditional software development life cycle looks like, and some obstacles for including security during development. Then I want to introduce to you a secure development framework based off of Microsoft's security development life cycle. And I want to share some implementation challenges that I've had with it and some tips for overcoming those. And then at the end, I'll conclude and you can ask me any questions you want. Does anybody know what SAN stands for?
International standard.
As far as I can tell, it stands for System Administration, Networking, and Security. But the maybe not so surprising thing about this is you see development or application anywhere in this acronym. No. So I think when you
Speak a little bit more about so the folks know.
sure thing. Sorry about that. So I guess I presume that when SANS was founded, it was mostly about networking and server security, not really about secure applications. Most companies spend a majority of their cybersecurity budget on infrastructure security devices such as proxies, firewalls, and intrusion detection systems. Yet most attacks are made to insecurely developed applications. So why do we neglect security during the development process? Applications are pathways into your network and data. Applications read, transmit, store, and modify data that's often critical to business function. Without the inclusion of security during the design, analysis, development, and testing phases, vulnerabilities can be inadvertently or maliciously released in a production environment. I suppose it's a little like having solid doors with good locks and having the door locked, but leaving the window wide open, right? So let's talk a minute about what a traditional software development life cycle looks like. So there are many different SDLCs out there. There's RAD, Rapid Application Development. It's not too well known. Of course, Waterfall, we all know. Love to hit that one. And then all of the iterative derivatives such as Scrum and stream programming and so on. But if you look closely at them, all of them have the same 5 fundamental phases. There's the analysis, design, development, testing, and release phases. So let's go through each one briefly. In the analysis phase, an analyst will gather business requirements and create a requirement specification document. This requirement specification document is used as input into the second phase, the design phase. This is where an architect or some other technical person will create a system design document. And the system design document serves as the overall system architecture, describes the overall system architecture. And also in this phase, the testers create a test strategy. The system design document is then passed to the development team, where work is divided into modules and coding begins. This is the main phase or main focus for developers, and is usually the longest phase of the SDLC. After the coding is developed, it is tested to make sure that it satisfies the original business requirements. It is in this phase that functional, non-functional, integration, and user acceptance testing are performed. After the successful testing, the product is delivered or deployed to customers for use and beta testing. Inevitably, bugs and new requirements will be discovered in this phase, and these will be reported to the development team for fixing or additional enhancement. That's why this is also sometimes referred to as the maintenance phase of the SDLC. So why is it security given more consideration during development of the traditional SDLC? Well, one reason is that security is not part of the project, but is an afterthought. Thoughts like, my app is internal, it doesn't need to be secure, or we'll find and fix vulnerabilities before release, or my favorite, we're out of time and money, we'll fix vulnerabilities after release. Does that ever happen?
Absolutely.
Another reason is the misconception that developers just build software and security professionals secure it. Right? Security professionals assume that developers know how to write secure code, and developers assume that security professionals will find their vulnerabilities. Both assumptions are usually wrong. Another common problem is that organizations discover problems when they're most expensive to fix at the end. As software complexity increases, vulnerabilities become more and more difficult to find and fix. By this time, projects are already behind schedule and over budget. What ends up happening is a compromise. Projects agree to fix the most critical vulnerabilities found, but they compromise and accept the risk of less critical vulnerabilities, right? Many studies have shown that the cost to fix software defects increases the further along the development life cycle is found. Let's look at a simple example to understand this. Let's say there's a development project that has a business requirement that allows users to log in, right? But no security requirement about how the credentials are to be stored. So what's likely to happen is that the credentials, password, are going to be stored in a database in clear text. If the project is, if the team is lucky, a bright analyst will recognize this isn't a good security practice and suggest encrypting or hashing the user password before storing it. But more likely, this won't be noticed until at least the end of the design phase, in which time that architect or technician will have to update the design specification. If this problem isn't found until the end of development, then all the code that handles user passwords will have to be re-implemented, plus the adding to the functional, non-functional requirement and updating the specification. If this problem isn't discovered until the end of the testing phase, then all the other activities, the adding the non-functional requirement and updating the specification and recoding will all have to happen. But anything that handles user passwords will also have to be retested. And worst of all, if this isn't found until after release, either the project or the company will decide to accept the risk, or if they decide to bite the bullet and re-encrypt or encrypt or hash existing clear text passwords, this gets really complicated and risky and obviously costly. So So the cost to fix software defects increases exponentially as time goes on. And this doesn't take into account the longer you wait, the more expensive it is to fix. And that's because the original developer has moved on to another project or another company. And there's a good chance that that developer has been replaced by a junior developer or an offshore developer that doesn't have the original context of the application or the code. So how do we catch security defects earlier on in the development lifecycle? Introducing the security development lifecycle. The goal of the SDL is to reduce the number and severity of vulnerabilities in custom developed code. It's also to meet existing compliance requirements such as SOX, PCI, and SIP, and to adapt to new compliance requirements as they come along. Some of you may be aware, remember a couple of years ago when PCI version 2.0, PSS 3.0 came out, which increased the scope of PCI quite a bit. It's also the goal of the SDL to respond to security incidents quickly and efficiently to reduce the impact of an attack on the organization. And to reduce the cost of developing software by streamlining the process. Security development lifecycle starts with the same 5 phases as a traditional SDLC, but adds training and a response phase to the SDLC. The security development lifecycle can be broken into 3 parts: education in the form of ongoing security training, process improvements in response to new technologies and threats, and accountability through process compliance and metrics to help guide future changes. In the training phase of the SDL, the goal is to create a baseline level of security knowledge for ideally all project team members to enable the development of secure applications and to meet compliance requirements. The requirements phase has 3 activities, which are to gather security requirements, establish quality gates and bug bars, and to conduct a preliminary security and privacy risk assessment. For those of you who don't know, a quality gate is a threshold, is a checkpoint to ensure that you don't go to one phase without completing all the activities to the prior phase. And a bug bar is a severity threshold for vulnerability. So say you have a high-risk application, let's say all high and medium vulnerabilities have to be fixed before moving on. We'll get into, in a little bit, I'll touch on the preliminary security and privacy risk assessment, but it's important to point out, I guess, that it's preliminary at this point because what it'll do is drive the amount of rigor in the subsequent phases of the SDL. Later on, after the product is developed, we might have a risk assessment for the vulnerabilities found. That's a more detailed risk assessment. The third phase of the SDL is the design phase, which includes establishing design requirements for security, analyzing and reducing the attack surface as much as possible. The attack surface is the number of ways in which an attacker can exploit weaknesses. And build a threat model. A threat model is a formalized way to assess vulnerabilities, threats, and countermeasures. The build phase of the SDL has 4 activities. The first one is to compile a list of approved tools that the developers can use, to have them avoid unsafe functions. There are often functions in development frameworks that are not known to have vulnerabilities. And to remove any default or test accounts. And this one also applies to sample code. It's quite common for developers to go on Stack Overflow or another site like that, copy and paste code, but they don't really understand how it works. And lastly, in this phase, to perform static code analysis. So static code analysis, for anyone who doesn't know, is analyzing the application that's not running. So advertising the source code for vulnerabilities. In the verification phase, the first activity is to perform dynamic analysis. Now, dynamic analysis is analysis of the application while it's running. And an example of a type of dynamic analysis is fuzz testing. And fuzz testing is inputting gibberish or random data in the application trying to reduce failure. Also in this phase is an activity to review the threat model and attack surface. So as I'm sure is very common, after development, it's common for for the application to deviate from its original design and original requirements. Maybe the developer came up with some great idea that wasn't thought of and it was pointed out. Or maybe the requirements changed and the client asked for something different. So we want to review the attack surface to make sure we didn't increase any risk to the organization. In situations where that are more higher risk, we may want to perform a manual code review in this phase and a penetration test. These can be quite lengthy and costly, so sometimes these two activities are performed by a third party at great expense. In the release phase of the SDL, we want to create an incident response plan that's specific to the application. And the reason for that is you might have an incident response plan for your network or for your servers, kind of a one-size-fits-all. But applications are so different from one another that it's really a good idea to have a response plan for each application because they're so different. And finally, to conduct a final security review in order to certify that all security requirements have been met and to archive the documentation. So obviously, preventing an incident is more cost-effective than responding to one. But if an incident does occur, being able to effectively execute the incident response plan is essential to reducing the impact of an attack on the organization and its customers. So after an incident is dealt with, the organization should also conduct a retrospective to determine what went wrong, why it went wrong, and if there's any way to improve the process to make sure it doesn't happen again. Of course, there are hurdles to implementing any change, and this is no different. One of them is first you must get management support. And unless your company has unlimited resources, it might be difficult to gain support for implementing all the security development activities contained within the SDL. One way to deal with this limitation is to partially implement the SDL. But this approach might leave your most critical applications vulnerable to attack. Another approach could be to only implement the SDL on the most critical or highest risk applications. However, this approach may lead to confusion if the team is required to follow the SDL on some, but not all development projects. Perhaps a better approach would be to include security on all development projects, but reduce the amount of rigor on low to medium risk applications. A risk-based implementation keeps the security in the mind of the development team while reducing the amount of rigor on less risky projects. After management support, you want to get developers to buy in. Security is fascinating, right? That's why you're here at 7 o'clock on a beautiful summer night. So it continues to intrigue with stories of sophisticated attacks, sometimes comparing attackers to James Bond of the cyber world. There's good reason why Stuxnet is featured in Vanity Fair and Mr. Robot is a popular TV show. How many people watch Mr. Robot? It's interesting show. However, despite the high general interest in security, developers time and time again fail to follow secure coding best practices. How do you transfer that security spark to developers when it comes to writing code. One way is to get one way to get them into security is to provide feedback early and often. Ideally, within their development environment if possible. This on the screen is a picture from Checkmarks, which has an ID-like development environment-like code window. And it provides the visualization on the right here, which is a graph that shows how the input, in this case, enters the application and ends up in the output. So it's a great visualization and one of the main features that I really liked about Checkmarks. It's also helpful to track code quality over time and make adjustments as early and as often as possible. Another good practice is to provide a strong support system for developers. Use a wiki or a forum to encourage information exchange between developers. After a fix, provide constructive feedback on the quality of the fix. And establish a shared knowledge base of coding vulnerabilities and secure coding best practices. Last but not least, make it fun if possible. Right? Use gamification and like capture the flag and bug bounties to increase developer engagement. Stack Overflow, for example, uses reputation and badges to motivate users to contribute, and has become one of the best resources for programming information on the internet. Finally, for success with secure development, there must be compliance and governance. It should include clear roles and responsibilities, code review, a good, solid code review process, and a good bug tracking system. And so for bug tracking and code reviews, use a tool like Visual Studio Team Services, like shown here, and adopt a robust branching strategy and gated check-ins to enable reviewers to review code prior to being merged into the master branch. This slide shows a picture of a pull request and conversation with developers that was done during code review, explaining, where the problem is and what the. You can also tag particular bugs in the bug tracking system. The SDL should have clear roles and responsibility, which includes two distinct roles: someone with authority to drive security and somebody on the project that's close to the solution. So the person that to drive security, it can be known as the security and privacy advisor. The advisor role is filled by a security subject matter expert from outside of the project team and must have the authority to accept or reject implementation plans. The advisor is responsible for monitoring each phase of the development process and reporting compliance or non-compliance of security requirements. This role can be filled by a security analyst or a manager. If the person close to the solution is known as the security and privacy team champion. Team champions should be development subject matter experts and be responsible for coordinating and tracking security issues for the project. This role can be filled by an architect, a developer, or a development lead or development manager. One role without the other is likely to cause the implementation to fail or have limited success. However, both roles may be filled by the same individual as long as that person has the appropriate skills, expertise, and is in the right place within the organization. Hopefully, by this point, you've learned a little bit about a few practices that can help your organization add security to the development processes. Although each activity of the SDL is generally considered a good security practice, there's no one-size-fits-all for secure development solution. Development and security teams should tailor their security development practice to the technologies, resources, and business practices of their organization. That said, it can be argued that even a few security processes can lead to improvements in the security and privacy that exceed the value of the individual activities. Are there any questions?
So we don't use SDLC, but we have our own application lifecycle management tool that we use at work, and I'm part of the testing team in that whole cycle. One of the things that I've heard from others that have been on the testing team for a lot longer than me, as well as some of the practices that I've seen, is that we don't get enough information from the developers in their code as far as comments when they are actually writing the code for documentation and whatnot. So when they write the code and it's just a bunch of code language and they don't have any comments in there, when I'm going through and doing application security testing, I'm just running off the hip without being able to decipher this is what he intended for this part and this part and this part to review first. Does the SDLC address any of the documentation side for developers?
There is, I'm of the school of less comments because if you've ever heard of code clean, the code clean code,
Yeah.
that the comments are generally a crutch for bad code or cryptic code.
Mm.
I agree there's certain situations where comments are needed, but it should be.
We have a phase when we roll out of testing and go into UAT, comments get scrubbed out of the code while the original code is saved on the development side. So when they need to go back and look at code when something fails, if something fails in the production side, that they can go back and look at this part of the code failed, look at the original comments from the developers.
Is this JavaScript code or what kind of code is it?
We test very different codes. We have JavaScript, we have Python, KSM, we have HTML. So there's a lot of applications that my test team has to go through, depending on what side of the company we're doing the testing for the applications. So there's a lot that my team has to deal with.
Well, the SDL, I mean, it's kind of outside the scope of a software development life cycle, where the SDL, whether there's good comments or whether the code is written cleanly or modularized appropriately.
Okay.
I see your point. So you're doing static analysis on these?
Yeah. So for ours, when the development team is done, we'll do a code drop, and they'll take everything from the development systems and push it all onto our testing systems, which is essentially a carbon copy of our production system. So everything that's currently live, what we have on the test system is the same as theirs. So when we push it onto the testing system, we'll run mock data through all of the application, all the different points of the application touches, and see how it reacts, see if it matches up with our practices, see if it meets all the different requirements. And if it does, a lot of times, most of the we run analysis for the different jobs. Some of them we can't run analysis. We have some HTML applications that I can't run through there, so we have to manually go through and look at it, push it, do network forensics on it, see what it's doing, all the testing against it. But
The reason you need the comments is for security.
yeah, the comments get removed in UAT when we push out, because if anybody is able to see the background, then they'll see all the comments too.
Yeah, it's not really part of the SDLC to dictate their company's policies for IT.
True. I was more or less speaking in general, because testers, analysts, and developers are common throughout all companies.
Yeah. Good point. don't really have a good solution for that. We've had similar issues here at Consumer Energy. The bug tracking system and getting that visual is really important. Seeing the trend of, I've used the trend of increase in the number of failing unit tests, for example, or the number of issues that, I don't know if you've heard of ReSharper, but it's a code quality, code analysis tool built in plug-in for Visual Studio, and for quite a few iterations on a project, I watched the number of issues that it detected go up, and I kept reporting them, sprint after sprint, until finally got somebody's attention and said, hey, we've got 10,000 issues here. We need to start making it go the other direction. So those visualizations, in my mind, are the most important thing, getting it out in front of project managers and development leads, and just making them aware of it. Just report it, just get it in front of people and say, hey, this is the fact, here it is, do what you want with it. But being aware of it, I think managers and even developers start to get a little uncomfortable with week after week, they're seeing that the number of failures or the number of code issues increase. The same?
So, two-part question. What is your favorite and least favorite languages? And do you believe there is a value security starting languages like Rust?
Well, I'm not familiar with Rust. I'll start with my favorite language. It would be C#. And my least favorite language. Well, that's a good question. Probably. I know there's Colo, maybe. There's got to be. I'm drawing a blank. There's got to be one I dislike even more than that. What's that? Punch cards, yeah. Good question. Thank you.
Quick question on what we've seen in terms of trends around the maturity of the sort of secure coding techniques specific to different languages. I know a lot of secure coding is focused for OAuth and web-facing applications. And what about the areas like ABAP or SAP or other languages that are not web-facing? We've seen trends where there's things that can be done to help secure those applications impact that are not web-facing, or specific languages that are more focused on others that we've seen.
Well, I remember during the science courses that I took, I remember PHP was picked on quite a bit, and even Java as a framework that doesn't lead you down the path of security, and .NET sifted to the top as being a relatively secure framework to develop on. I don't know a whole lot about ABAP, but I have been seeing more and more vendors coming out with static code analysis for ABAP. I haven't used any of them, but it seems like to me that they're trying to catch up.
Would you say that you can get a large value of risk reduction for looking at secure coding for internally isolated applications that are not web-facing as well, versus the web-facing applications that are rather more common attacks like system and stuff and also restricted separation? Something where suddenly we look at sort of like the firmware or vendor products where there may not be web-facing, but you question how is this code developed? Who would attack this because of the cyber network?
I seem to remember the big JP Morgan attack that happened a year and a half ago. I don't remember the specific details, but the attackers were very sophisticated, and they ran through some obscure web application that wasn't really a high-risk application. And once they made their way on the network, they exploited some weakness in internal application that wasn't externally facing. So, yeah, personally, it's like you can't boil the ocean, so you start with the highest risk application, start with web customer facing or externally facing, and work on all web applications and then applications that are critical to your business. You work your way down, but I personally think all software development projects should go through some kind of a code review, something to consider security for that very reason is that good attackers are going to use a weakness in an application you might not care about, and they're going to use it to attack an application you do care about. So, does that answer your question?
Yeah, no, that helps. It's just trying to delineate, you know, every time I hear secure software like that come up, it's always in the context of what person application.
Usually
It's trying to put a little more context to it when it's actually not an application. I think the answer is that.
absolutely it does apply, and I struggled with that a lot before. You know, like I mentioned earlier, that a year and a half ago, PCI released DSS 3.0, so that affected consumers' energy quite a bit. Right? So all of our developers got training in secure coding. Well, a lot of our developers are ABAP, SAP developers, so they don't develop web applications. But almost all the training material that I found was about how to secure web applications. So I remember having feedback from some of the developers saying, "Hey, I don't write web applications. Why do I care about this stuff?" It's a good point. It is still relevant, but the training material hasn't come up. Any other questions? Was this valuable?
Yeah, definitely.
Well, thanks for coming, and that's all I have.
Oh, thank you.
All right, for those who are new, we'll probably be heading